Kinematics is a branch of physics that studies the motion of objects without considering the forces or masses that cause the motion. It focuses on describing motion using mathematical equations and concepts such as position, velocity, acceleration, and time. Here are the key details about kinematics. 1. Basic quantities in kinematics. Position, x. 1. Describes the location of an object in space relative to a reference point, origin. 2. Represented as a coordinate in 1D, x, 2D, x, y, x, 2, y, x, y, or 3D, x, y, z, x, y, 2, z, x, y, z. Displacement, delta x. 1. The change in position of an object. 2. Formula, delta x equals x final minus x initial, delta x equals x underscore text final. X underscore text initial, delta x equals x final minus x initial. 3. It is a vector quantity, has both magnitude and direction. Velocity, v. 1. Describes the rate of change of displacement with time. 2. Average velocity, vg equals delta x delta tv underscore text, avg equals frac delta x delta t, vg equals delta t delta x. 3. Instantaneous velocity, v equals dx dt, v equals frac dx dt, v equals dt dx. Acceleration, AAA. 1. Describes the rate of change of velocity with time. 2. Average acceleration, aavg equals delta v delta ta underscore text, avg equals frac delta v delta t, aavg equals delta t delta v. 3. Instantaneous acceleration, a equals dv dt, a equals frac dv dt, a equals dt dv. Time, ttt. 1. A scalar quantity that measures the duration of an event. 2. Equations of motion, for uniformly accelerated motion. These equations are applicable when acceleration is constant. First equation, v equals u plus atv equals u plus atv equals u plus at 1. O. Initial velocity. 2. v, final velocity. 3. AAA, acceleration. 4. TTT, time. Second equation, s equals ut plus 1 2 at 2, s equals ut plus frac 1 2 at squared, s equals ut plus 2 1 at 2. 1. SSS, displacement. Third equation, v2 equals u2 plus 2 asv squared equals u squared plus 2 asv2 equals u2 plus 2 as. Fourth equation, average velocity, vg equals u plus versus 2 versus underscore text, avg equals frac u plus v 2, vg equals 2u plus v. 3. Types of motion. Linear motion. 1. Motion in a straight line, 1D motion. 2. Examples, a car moving along a straight road. Projectile motion. 1. Motion in 2 dimensions under the influence of gravity. 2. Horizontal and vertical motions are analyzed separately. Circular motion. 1. Motion along a circular path. 2. Key quantities, angular velocity, omega, angular acceleration, alpha. 4. Graphical representation of motion. Position time graph, x minus t x t x minus t. 1. Slope represents velocity. Velocity time graph, v minus tv minus t. 1. Slope represents acceleration. 2. Area under the curve represents displacement. Acceleration time graph, a minus ta minus t. 1. Area under the curve represents the change in velocity. 5. Example problem. A car starts from rest, u equals 0, and accelerates uniformly at equals 2 meters per square second, equals 2, text, meter per second, squared, equals 2 meters per square second. Find the velocity and displacement after t equals 5 cent equals 5, text, s, t equals 5s. Solution. Use the first equation of motion, v equals u plus at equals 0 plus 2, 5, equals 10 meters, sv equals u plus at equals 0 plus 2, 5, equals 10, text, meter per second, v equals u plus at equals 0 plus 2, 5, equals 10 meters per second. Use the second equation of motion, s equals ut plus 1 2 at 2 equals 0 plus 12, 2, 52 equals 25 milliseconds equals oot plus frac 1 2 at squared equals 0 plus frac 1 2 2 5 squared equals 25 text m s equals oot plus 2 1 at 2 equals 0 plus 21 2 52 equals 25 meters. Answer 1. Velocity 10 meters per second 10 text meter per second 10 meters per second. 2. Displacement 25 meters 25 text m 25 meters. Kinematics provides the foundation for understanding motion and is crucial for studying dynamics and other areas of physics.